Welcome guys to today's class. In today's class, we want to see how to solve these problems we have. These questions you are seeing are coming from an important topic in chemistry called buffer solutions. Yes. What do you know about buffer solution? I would like to tell you that buffer solution is any solution whose pH resists to change on addition of small quantity of acid or base. Yes, remember, on small addition of acid or base. So if you carry large quantity of acid or base and pour into it, it will change. The pH will definitely change. So it's only when you add the acid or the base in small or little quantity, that is when it resists the change of its pH. Okay, so we say buffer solution, they are solutions whose pH resists to change on addition of little quantity of acid or base. These buffer solutions have been used in the medicine, in laboratory, in fact in science. If you check malaria test case, you will see that it makes use of what? Buffer solution. They use it to do the test. If you check COVID-19 test case, they also make use of buffer in running the test. So these buffer solutions have good application in the field of science. Now, this buffer solution can be divided into two: acidic buffer and basic buffer. Remember, I said can be divided into two. That doesn't mean that we don't have other types, but we say we want to classify them into two: acidic buffer and basic buffer. What do we mean by a buffer being called acidic buffer? When do we call an acidic buffer an acidic buffer? When do we call a given buffer an acidic buffer, so to speak? That means if you have a buffer that contains acidic buffer, is any buffer that contains an acid and its conjugate base. We call them what? An acidic buffer, so to speak. What do we mean? This is an example of an acid, a weak organic acid, ethanoic acid. Then this is an example of conjugate base of it, sodium ethanoate, so to speak. When you have a solution containing this and this, we call that solution acidic buffer or acid buffer. Are you getting it? When do we call a buffer solution basic buffer? When do we call a buffer solution basic buffer? It means it contains a base and its conjugate acid. Conjugate acid. Example, ammonium hydroxide and what? Ammonium what? Chloride. This is the conjugate acid of what? Ammonium hydroxide, and ammonium is the base. So when you have this type of what? Combinations, we can call it acid buffer, basic buffer. Now, it's important that when you are solving question on buffer, likely questions you can be seeing is pH. Find the pH of this buffer. What do we mean by pH of a buffer? It means the measure of what? The degree of acidity or alkalinity of that word buffer. The measure of the degree of acidity or alkalinity of the word buffer, we'll call it pH of that buffer. Are you getting it? Now, when we want to find pH of acid buffer, it means that when we say pKa plus log concentration of the word salt or over concentration of the acid. Now, we can also get pOH of a what? pOH of a what? Basic buffer. We are talking about POH because every basic buffer, most of them have what? OH group. Now, we say it is pKb plus log what? Salt over base. Now, I want to let you know that use of mathematics can be applied here. There are a lot of mathematical work they can use to confuse us here. If you check in some textbook, they can say pKa minus log. Once you put minus here, it means you invert this. It becomes acid over salt. So when you see pH of acidic buffer go this way or this way, know that they are saying the same thing. Likewise, this pH of basic buffer, pKb minus what? Log of what? Base over salt. It is just mathematics. Once you put minus here, you change here. Once you put plus here, it goes this way. Now, it's important for you to know that POH plus pH equals to pKw. Yes. When you hear POH, it means minus log of what? OH. When you hear pH, it means minus log of what? H. So minus log in this topic is called P. Minus log is called P. Then pKw also minus log of Kw. That is the ionization constant of the water. Minus log of the ionization constant of the water. All these things are coming from the topic of ionic and chemical equilibrium in chemistry. So I want you guys to note that minus log of OH means POH. Minus log of hydrogen ion means what? pH. Minus log of Kw means pKw. Note it. So when you add the what? POH with pH, you have pKw. Then when you multiply OH ion with what? Hydrogen ion, you'll be getting 10 raised to power minus 14. That is when you multiply them. You have to be noting this formula. Then when you have pKa plus pKb, you will be having it to be pKw. And note that pKw is equals to 14. It's constant. pKw is constant, is equals to 14. Now I want to see how to solve this problem we have on the board. I haven't noted important points on buffer. Yes. Remember, their pH resists to change on addition of small quantity of acid or base. Let's see how to solve this problem we have on the board. Question 1. What is the hydrogen ion concentration? This bracket, close bracket means concentration. What is the hydrogen ion concentration in mole per liter of a solution 0.2 mole per dm cube in this and 0.1 mole in this? So what they mean by in this mean 0.8 of what? And this of what? They are telling you the concentration of the sodium ethanol, which is the salt, and of the what? The acid. Now, for you to solve it, they gave you the Ka. You tell them that pH is equals to minus log of what? Hydrogen ion concentration. And is equals to, what is the pH of this buffer? Is this a buffer or not? How do I know whether this is a buffer? You can call this a buffer because it has an acid and its conjugate base. Because we say acidic buffer is a buffer solution that have an acid with its conjugate base. And so this is an acidic buffer, so to speak. So we now say is equals to log what? Is equals to pKa plus log what? Salt over acid. As we said. What is our pKa? pKa wasn't given. They gave us our K. That means to get our pKa, we will tell them that since Ka is this, pKa is minus log of Ka equals to pKa equals to minus log of what? 1.8 times 10 raised to the power minus 5. Then we press it in calculator, minus log 1.8 times 10 raised to the power of minus 5. So that gives us 4.745 answer. That is our what? pKa. I will put it here. Since pH is this, I will now say minus log of hydrogen ion concentration, which is your pH, is equals to what? 4.745 plus log what? What is the salt? Quantity of salt? 0.2. All over 0.2. Can you see it now? That is acid, concentration of acid and salt and acid, so to speak. 0.2 over 0.2 will give you 1. Logarithm of 1. Remember when you see log, log means in base 10, a standard base. Are you getting it? So 0.2 over 0.2 will give you 1. Log 1 to base 10 is 0 in mathematics. Please, log 1 to base 10 is 0. Let's write it. Log 1 to base 10 is 0. I will now say that this is minus log of what? Hydrogen ion concentration equals to 4.745 plus 0. This. Now, remember we say minus log means it is in base 10. Now, I will say, take this minus, take it to the other side. It will be log hydrogen ion concentration in base 10 equals to. So that means anytime you see ordinary log without a base, it means it is in base 10. It is a natural base. Just have that secret at heart. Now, this one now, I will take this minus to this side, become minus 4.745. Then the hydrogen ion concentration, making it subject of formula, this 10 will lift this up from principle of how to convert logarithm to indices. So, to remove this logarithm, this 10 will lift this up, equals to 10 raised to the power minus 4.745. So I will be having 10 raised to the power of minus 4.745. The answer will now be 1.799 times 10 raised to the power minus 5. Mole per dm cube. And mole per dm cube means mole per liter. Mole per dm cube means mole per liter because 1 dm cube is equal to 1 liter. So that means our hydrogen ion concentration in mole per liter will be equal to 1.799 times 10 raised to the power minus 5 mole per liter. That becomes your answer to question number 1. To solve question number 2, 100 ml or 0.1 mole per dm cube ethanoic acid or acetic acid is mixed with 50 ml of 0.1 mole per dm cube sodium hydroxide solution, and the pH of this resulting solution is 5.0. What is the change in pH if 100 ml of 0.05 molar sodium hydroxide is added to the solution? Please, it's important for you to know that molar means mole per dm cube. Yes. Now, I want to know whether this is acidic or basic buffer. So, we have to represent what we are seeing with what? Equation. We have acetic acid plus what? Sodium hydroxide to give you what? Sodium ethanoate plus what? Water. The equation is balanced, right? Now we need to know the amount of this that reacted. The amount, they go by 1:1:1:1, right? Now we say number of mole of what? Acetic acid reacted. Number of this reacted equals to, you say 100 times 0.1 all over 1000. That will tell you how many moles of it reacted. You now say 100 times 0.1 divided by 1000. That will be giving us 0.01 moles. That means it's only these moles of what? Acetic acid that reacted. You do for sodium hydroxide, number of moles of what? Sodium hydroxide reacted will be equals to, this is 50 times 0.1 all over 1000. You now say 50 times 0.1 divided by 1000. That means we'll be having 0.005 moles. Mole. They are not more than 1 mole. Now, you notice that this quantity of sodium hydroxide and acetic acid, this one is higher than this. And they go by 1:1. That means that this is the acidic buffer because it has what? This and what? Is conjugate base. And we say that acidic buffer has an acid with its conjugate what? Base. If we say it is what? Sodium hydroxide, it doesn't have conjugate acid here for it that we will use. Now we say this and this, so acidic buffer. Now if here is 0.05, 0.005, because it's go by 1:1, this one is smaller than this. It means that here will be 0.005 because 1:1, 1:1 mole. So that means 0.005 for sodium hydroxide will react to 0.005 for ethanoic acid. Now once it reacts, how many of ethanoic acid will remain? The one that will remain is 0.01 minus what? 0.005. That will be giving you this remaining. So this will be what? Remaining. Yes. So they gave you the pH when we have this. You said that your pH is equals to 5 and is equals to pKa plus log what? Salt over acid. Concentration of salt over acid. Now this is 5. That means we are looking for what? pKa. That is what it means. Because we have gotten what? This react with this. This will now remain. And it will produce what? 0.005. And it will also produce 0.005 more of water. So this reacting with this will be producing this in terms of 1:1:1. So once this neutralizes with this, it will be remaining this of acid remaining. You note that the acid remaining is what? Acid remaining in that solution, first solution, is 0.005 mole. Then the salt form will be equal to 0.005 what? Mole also. So we are looking for pKa. We will be saying 5 equals to pKa plus log what? Salt is 0.005 all over what? Acid is 0.005. Now we say this over this is 1. Log of 1 is said to be 0. Therefore, pKa automatically will become 5. We have gotten our pKa. Now, in this same solution that is having what? 0.005. of ethanoic acid remaining. The base already have been neutralized. They said, what is the change in pH if 100 ml of 0.05 mole of what this is added to the solution? Wow. He said number of what? Number of what? Sodium hydroxide that will be reacting equals to 100 times 0.05 all over 1000. That will be giving 0.005 mole. That is number of sodium hydroxide of this that will be reacting when you put it what? When you carry 100 ml of this and put inside the same solution. That means this is another sodium hydroxide you are adding. And already we have 0.005 of ethanoic acid remaining in this first one when you added this. This will not be remaining. So this will go to neutralize it again. And once you neutralize it now, it will also go and form another what? 0.005 of sodium ethanoate. That means 2 sodium ethanol will be having. This plus this will be giving 0.0. We now say 0.005 times 2. That will be giving us 0.01. Therefore, what you'll be seeing here now, there will be no acid remaining here because the second sodium hydroxide have neutralized the remaining acid. No base remaining, no acid remaining. Only salt and water is what we'll be getting. You will be having 0.005 plus 0.005. That will be giving you 0.01 what? Mole of what? The salt remaining. We call this what? What type of? This is a salt. And because this is a salt now, salt and water, that means that is what we'll be having. This is no longer, the result of this will no longer be a what? Buffer. It will no longer be a buffer. It will be salt and water. Are you getting it? So, as it is like this now, what you now do is, you now say, to get the pH of this, what is, we call this, is it acidic salt or basic salt? Is it acidic salt or basic salt? That is the question now. How we know whether it is acidic salt or basic salt is, we say, this is sodium and this. It's gotten from sodium hydroxide plus what? A weak acid. This is a strong base and this is a weak acid. So this will be a basic salt. This automatically will be a basic salt. So basic salt. Because strong base will overshadow the weak acid. So it will give you a basic salt. So the resultant of what we'll be having is a basic salt. So we have this form and another 0.005 of water form. So water is 0.001 total. The basic salt is also 0.001 because when you add this and this, it will give you what we have here. That means we will be going for now pH of a what? A basic salt. So since we have gotten the final thing to be a basic salt, we say pH of a basic salt. pH of a basic salt is equals to half pKw plus what? Half pKa plus half log C. There is need for you to check our class on ionic and chemical equilibrium still on Chidons Daniel YouTube channel, so that you will see how we derive this formula, so to speak. Yes, because we had two formula there where we said pKw minus half pKb plus half log C. This is with respect to when pKa is given, and this is with respect to when pKb is given. Now, how do we get our C, which is the concentration? To get your C, you say that we have 0.01 mole of what? CH3COONA, which we call a basic salt. Are you getting it? That is the total thing we have, plus 0.01 what? Mole of what? Water. That is the total thing we have. But this is a salt. The salt component is what you are looking at. Are you getting it? Now convert what we have in this salt. Convert it to what? Liter. Convert it to mole per dm cube or mole per liter. How do we get it? You say that what we have here is 100 ml plus another 100 ml of what? Sodium hydroxide will give you a total of 150 ml. Then plus another what? 100 ml of sodium hydroxide will give you a total of 250 ml. That means this 0.01 mole is inside 250 what? Mils of what? The solution. The solution, that is salt and water. Then you now say 1000 ml to 1000 ml of what? Solution. What will it be? We'll cross multiply. It becomes 1000 times 0.01 all over 250. That will be giving us what? This divide this is 4 times this 0.04 what? Mole per what? Liter. That will be the concentration of that salt in that total solution. Remember what we said. How we get it is we get the total volume of the solution we have. Solution containing this 100 ml of this, 50 ml of this, that is 150. And 100 ml of another sodium hydroxide added, that is 250. That the entire solution is 250 ml volume. Then we now put it here. We now bring it here. pKW, as we noted, is 14. So half pKW should be 7. So the final pH, when you add this one, will be equal to half times 14 is 7 plus half times what? 0.04. No, half times, what is our pKa? We got our pKa to be 5. Yes, plus half times 5, that will be 2.5 plus half log what? 0.04. We'll compute it. That will be giving you 9.5 plus, we now say 0.5 times log 0.04. That will be giving us minus 0.699. So we now say 9.5 minus 0.699. That will be giving us 8.801 to be the answer. That is the final pH when you add what? Another sodium hydroxide into it. You see why we say it's a basic buffer. You see the pH is high, meaning it's in base. It's a basic buffer. It's now a basic salt, no longer a buffer, because this second sodium hydroxide are finally neutralized the what? The remaining ethanoic acid, as we said. Now, but they say, what is the change in pH? Change in pH is equal to this final pH minus initial pH. And what is the final pH? We have it to be 8.801. Initial pH is 5.0. They gave it to us, pH of 5.0. Therefore, our answer will now be what? 8.801 minus 5.0. That will be giving us 3.801, approximately 3.8. That will be the final change in pH of question number 2. Now to solve question number 3, 50 ml of 0.1 molar sodium hydroxide is added to 75 ml of 0.1 molar ammonium chloride to make a basic buffer. If pKa of ammonium ion is 9.26, Find its pH. Now, remember we said this is coming from buffer solution. For acidic buffer, it must have an acid and a conjugate base. For a basic buffer, it must have a base and its conjugate what? Acid. And so, let's see how it goes. Sodium hydroxide plus ammonium chloride will be giving you what? We'll be having sodium chloride plus what? Ammonium hydroxide. Now, because the pKa given is for ammonium, it means that this buffer contains a base and is what? Salt. That is the conjugate acid of it. And so, this goes by 1:1:1:1, so to speak. Now, let's get the amount of moles of sodium hydroxide that reacted and the one for ammonium chloride that reacted. Amount of sodium hydroxide reacted equals to 50 times what? 0.1 all over what? 1000. That is the formula. So you say 50 times 0.1 divided by 1000. That gives you 0.005 mole. You also say amount of what? Ammonium chloride reacted. That will be 75 times 0.1 all over what? 1000. That will be giving you 0.007 what? 5. 1, 1, 2, 3. That will be giving you 0.075 what? Mole. Now, this goes by 1:1. 1:1. Between these two moles, one is higher. Amount of sodium chloride is higher than amount of sodium hydroxide. And so, if here becomes 0.005, going by 1:1, it means it will react with what? 0.005, going by 1:1. That means once it reacts with this mole of this reacting with this mole of, because the amount of sodium hydroxide is lower than the amount of ammonium chloride. So if this reacts with this, the implication of it is that amount of ammonium chloride that will remain will be this minus this. That is 0.0025. 0.0075 minus 0.005 will give 0.0025 mole. Then 1:1 will be giving you what? 0.005 and 0.005. And we said we will be talking about base and its conjugate acid because it produces a basic buffer. We say pOH of a base or basic buffer is equal to pKb plus what? Log of what? Salt over what? Base. Now, when we are not giving pKb, we are giving pKa. And we noted that pKb equals to 14 minus pKa. That means 14 minus 9.26. 9.26. That will be giving us 14 minus 9.26. That will be giving us 4.74 to be our pKb. So I will be writing 4.74 plus log. What is a salt? What is a salt? The salt is what? 0.025 all over. What is the base? The base will be equal to what? 0.005. So I will be putting it in my calculator. 4.74 plus log bracket 0.0025 divided by 0.005. That will be giving me 4.44 approximately. That is my POH. Then my pH will be equals to 14 minus POH. My pH will be equals to 14 minus POH. What does it mean? It means that I will write 14 minus 4.44. And that will be giving me what? 9.56. That becomes our what? pH. That means once you check this and this, it will produce this and this by what? Decomposition method. Sodium will go with this, this will go with this. That means 1:1:1:1 in terms of their mole. So get amount of sodium hydroxide reacted. You have this times this divided by this 0.005 mole. Okay? Then get amount of ammonium chloride reacted. You will be having 75 times 0.1. 75 times 0.1 divided by 1000. You have 0.0075 mole. You say POH equal pKb plus log salt over bed. That POH of basic buffer. Now pKb will be equal to 14 minus pKa, and that is 14 minus 9.26, 4.74. Say 4.74 plus log. What is your salt? Your salt is 0.0025. That is this salt. And 0.005. You still put it in your calculator. You say that it will give you 0. Divided by 0. Then you will be having 4.44 as a POH. That means the POH of your basic buffer is 4.44. What about your pH? pH will be equal to 14 minus POH. That will be giving you 14 minus 4.44. That will be giving you 9.56. That is the answer for what? pH of that buffer. Thanks for watching this video. If you find the video helpful, don't forget to click subscribe, click like, comment, and share to your friends. We'll keep uploading more content that will help you.